Now let's prove the backward direction. Now I tell you that backward direction uses a very similar argument as a forward direction. So before you watch this video for the proof, maybe you want to try it yourself first. What you want to do is I want to play with those definitions and see what you get. And I believe most of you should be able to prove this direction by yourself. But if you don't, let me tell you the proof anyway. So for the backward direction, you're going to suppose that this trajectory GTUA ZM plus N is divergent. Then, by Maa-ler's compactness criterion, you have for any delta greater than 0, there exists a capital T such that for any t greater or equal to t, we have that GT UA z raised to the power m plus n intersection B delta is more than just the origin, where this B delta is the cube or the ball centered at the origin under the infinite norm of radius delta. Here's our goal. We want to show that this A, this n by n matrix A, is singular. By definition of the singularity of the matrix A, we want to find for any epsilon greater than 0 some q sub epsilon such that for any q greater or equal to q epsilon, there exists pq in Zm plus n such that we have those two inequalities hold. First is the infinite norm of aq plus p less than or equal to epsilon times q raised to the power negative n over m. And the second inequality is that the infinite norm of q is strictly greater than 0 and less than or equal to q. And to realize this goal, you need to take advantage of the definition or the equivalent definition by the Maa-ler's compactness criterion of the divergence of the trajectory. You want to carefully pick delta. So the question is how to pick delta and q epsilon using epsilon and capital T. This is a key question that you want to answer. And as I told you earlier, the proof will be very similar to that of the forward direction. So what you do is that you start with this property for the divergent trajectory. Notice that the intersection of this trajectory with B delta is more than just 0 for t greater than or equal to capital T. We have to determine this capital T later. This implies there exists a PQ in z raised to the power m plus n minus 0 such that if you consider the infinity norm, GTUA PQ, and this, by our computation before, is equal to the infinity norm of this vector. And this is supposed to be less than delta for some choice of PQ that is non-zero. And if you separate those two parts, this gives you the following two inequalities. The first is AQ plus P infinite norm is less than t raised to the power negative t over m times delta. And the second inequality is the infinite norm of Q being less than e raised to the power t over n times delta. Let's call those two inequalities the star. And as I said before, we denote this with an asterisk. So you must have seen some kind of connection between this and this. And the next thing we want to do is that we want to get this asterisk system from this star system. So in order to get asterisk from star, we need the following two inequalities. Namely, we want to make sure that the right-hand side in star is less than or equal to the right-hand side of the asterisk. Previously, in the forward direction of the Dani's correspondence principle, we wanted to solve this for t, because back then it was the choice of the capital T that we want to find. But now at this moment, our goal is to find Q epsilon. So we want to solve those inequalities for Q. So let's do it. So let's solve. Let's go for capital Q. And by computation, as we have done before, this is equivalent to the Q is greater or equal to e raised to the power t over n times delta, and less than or equal to this. So if you look at our first equation, this is epsilon divided by delta times e raised to the power t over m raised to the power m divided by n. And this is epsilon by delta raised to the power m over n times e to the t over n. So in order to make this solvable, we need that the right hand side to be greater or equal to the left hand side. Namely, we need delta to be, let's cancel e to the t over n and e to the t over n. To make this solvable, it suffices to make delta to be less than or equal to e over delta raised to power m over n. And this is equivalent to saying that what do we know about delta in this inequality? This is the same as delta being less or equal to epsilon raised to power m over m plus n if you solve this. So, as long as we pick delta to be less than e raised to power m over m plus n, as long as we make this pick, then for any q in the interval I of t defined to be this interval, we have that the asterisk holds for some pq in z m plus n. This is by our computations above. Because this system of inequalities will give us the implication from star to the asterisk. And the existence of p, q is guaranteed from here. So this is true. Now we are close to our goal. Remember, our goal is to find for any epsilon greater than 0 some q sub epsilon such that for any q greater or equal to q epsilon, there exists p, q such that the asterisks hold. Now we are able to achieve this for any q in this interval. As you can imagine, we are going to use the trick we used in the forward direction again. Namely, we want to take the union of those things. So let me write it down. We want to take the union of such things. T as an integer starting from the ceiling of capital T. Remember, this capital T is guaranteed by our assumption that this trajectory is divergent. So this capital T is already chosen based on delta. Although at this moment, we do not know how exactly we should pick delta. Later we'll determine this. But this T will depend on delta. And to this end, we need that I of t intersection I of t plus 1 is non-empty for any t greater or equal to capital T. Or equivalently, as before, the right end of the interval I of t is supposed to be greater or equal to the left end of the interval it plus 1. Specifically, this means this guy is greater or equal to this, the left end of it plus 1. And now let us simplify this. This will be, if you raise both sides to the power n, you get this. And this is equivalent to, so now you can cancel e to the raised to the power t and e raised to the power t here. So you get e by delta raised to the power m is greater or equal to e times delta raised to the power n. Now actually, in here we do not need that t is greater or equal to capital T. Because unlike what we did before, there's no t in the end. This is equivalent to 1 over e times epsilon raised to the power m greater or equal to delta raised to the power m plus n. And this is same as delta being less than or equal to 1 over e raised to the power 1 over m plus n times epsilon raised to the power m over m plus n. Now, as long as you make delta to be less than this guy, noticing that this part is less than 1. So once delta is less than this, it's automatically less than epsilon raised to the power m over m plus n. This is automatically satisfied. And at the same time, you can take this union. Because any two adjacent members in this union will have non-empty intersection as before. So as a result, this union will contain some infinite interval from q epsilon to infinity. And that is our choice for q epsilon. This is a question that we wanted to answer at the beginning. So this finishes the proof of the backward direction and the whole theorem.